Okay, these problems are very similar to the problems that can be expected to be appeared in the paper. Like these are very similar to those examination paper questions, but not they are not the same, but they are similar, right? But it's little bit to the more difficult side, right? Okay, so we'll start with one. This problem usually appears as problem 2, the modulus functions. Here, I'll first write this. You have the paper, so I don't have to give you the summary. We have to sketch these two. First, I'll sketch this without the outer modulus. So it will be like this. So first, you find the value of x for which this becomes 0, which is 2. And when you substitute 2, you get 0 for this. At that point, the value of y is -1, right? 0, -1. Because when x is 2, this is 0, 0, -1. So value of y is -1. So the vertex occurs at this point. It's a v, right? After that, if you introduce the other modulus, what happens is that you have, okay, I'll come up with this example. If you graph y is equal to x, you get a line like this, which goes through the origin and whose modulus is 1. Now, if you introduce a modulus function outside, it will be like this. It's a v. So what happens is that whenever the function is positive, it remains the same. But if the function is negative, you have to take the mirror image of that. So case is the same in this particular part. Here, in this interval, like 1 to 3, this function is negative. Therefore, you have to get the mirror image of this part only. Leave the other two parts as they are, and you get this. When you take the mirror image, this will be 1. We have to find the equations. Now, initially we sketch this. So to the right-hand side, it is x minus, this is represented as it is. So this part will be x minus 2 minus 1, which is x minus 3. This one. There, this part appears as its negative value, like minus x plus 2. So it is minus x plus 2 minus 1. So it is minus x plus 1. And you can clearly see that this goes through 1, therefore the intercept is 1. So everything is right. Now, in this case here, we simply take the negative value of that. When you take the mirror image about the x-axis, you simply make the sign different, like there's a sign change. If it is -1, here it is 1. If it is minus half, this is plus half. So simply you multiply this by -1. So it is x minus 1. Minus x plus 1 turns out to be x minus 1. Now here, this should be exactly the negative value of this. So minus x plus 3. Now this is a piece of cake. It is just x minus 2 modulus. So it is 0 when x is 2, and it's a v. This side it is x minus 2. Here it is minus x plus 2. This is a first paper problem. I mean, this problem appears in the first paper. So by symmetry, you can straight away say what A, B are. If you want, you can solve these equations and find A and B. It is in fact the midpoint of this line segment. It is 1.5 and this is 2.5. If you want, you can solve it. solve these two. This is x minus 1 and this is minus x plus 2. It happens at the point of intersection, the value of x is a. So you can simply write it as a minus 1 is equal to minus a plus 2. So 2a is 3 and a is 3 over 2. Similarly, b turns out to be 5 over 2. Now the inequality we are solving is this. So here this one should be less than the other, v. This is a w, this is a v. So w should be less than v. So here, the graph of w is always less than v up to this point. So you have to include that part up to a. And after that, in this interval, w is greater than v, or the function with double modulus, I mean pair of modulus functions, will be above v. V equal make the right? Their w is greater, so you shouldn't include that part. And afterwards, again, w is sitting below v. And at the same time, you have to consider the points of intersection. So basically, this is the interval. X is in minus infinity to 3 over 2. We had only one problem like this only in 2022. Right. Now we'll do the second. Okay. Here you have to go for a substitution because here x goes to pi by 3. Here also you have x minus pi by 3. So we'll take u as x minus pi by 3. That means when x goes to pi by 3, this is pi by 3 minus pi by 3, which is 0. After that, it's a piece of cake. You can, at the same time, this is, if you pull out 3, it is 3 minus pi by 3. Okay, so limit u goes to 0, tan u. And if you substitute, okay, x is equal to u plus pi by 3. Right? Now, when you have a tan, we don't know what to do with that. Therefore, earlier we had the results in the syllabus, like tan u over u is 1. Now we don't have it in the syllabus. Therefore, we have to convert it to sine and cosine, convert it into sine and cosine. So this is sine u over cosine u, and this will be like 3u plus pi minus pi. So it is 3u. Now divide both upstairs and downstairs by u. So you have this. You can keep 3 here. You have sine u over u. Now take the limit. You can straight away tell what the answer is, but you have to use the properties of limits. This can be computed by substitution. It's not a standard formula. Now this is 1. That is 3. Because cos 0 is 1. So it is 3. Third. Even though this in this particular paper, this appears as the second problem, in actual paper, this appears as the 5th problem. 3. We cannot do anything with this setup. Bring all the cosine functions to one side. So this will appear as cos 4x minus, it is sine 6x minus sine 4x. Now apply CD formula, right? This is 2. When you have cos C minus cos D, you have something special. Everything will be in terms of sine. Like cos C plus cos D can be expressed in terms of cosine only. It is in terms of sine. 2x minus, sorry, first you add them divided by 2. Then you subtract, but you subtract in the reverse order in this particular formula, right? Cos C minus cos D is 2 sine C plus D over 2, then sine D minus C over 2, right? Therefore, you have to subtract it in this way. 4x minus 2x is 2x divided by 2, you get x. Here, sine C minus sine D. So inside sine, you have the same shape. Difference divided by 2, sine x. Then the other one is cos. Because in the case of CD formulas for sine, you have both sine and cosine. So in this case, you have the sum divided by 2. You can bring that to one side. Don't divide it by sine x, it is wrong. You cannot divide the equations by variables. Cos 5x. Hmm. Yeah, we get stuck with this. Sine 3x, we are left with sine 3x, but still we can solve it. It's not a big deal. We'll do it. We'll pull out sine x. Right. Now we have two solutions, right? Either sine x is equal to 0 or how do you solve this? It's kind of difficult, right? We'll have it like this. Now cos 5x is sine 3x. If you have the same angle, there's no problem. If you have the same angle, you can divide it by cos 3x. Like sine 3x minus cos 3x. But here it is not the case. This has the large angle, so I'll take that. I'll write cos 5x is equal to sine 3x. Now we'll come up with this way. Now we can, now since you have cosine and sine, uh, there's a way out. Otherwise, it will be difficult. Like say, cos 5x is equal to tan 3x or something. Then it will be a little difficult for us. But in this case, it is easy. You can write this in terms of cosine because they are co-functions. You can write this as cos pi by 2 minus 3x. Now you can treat this as your solution. Even though it contains x, you have similar problem in 2019. In 2019, there was not the same thing, but there's an equation that can be solved in this, and that was solved in this way. In the again, the marking scheme, this method is given. That කලින් මොකද දුන්නම සමහර ටීචර්ස් කියනවා ඒකට ලකුණු දෙන්නේ හරියම කියලා. එහෙම කරන්න පුළුවන්. හරි. 19 වල මේක ආවා එහෙම. 2019 මේ වගේ not this same thing but something similar. I can probably give you that problem as well. Okay. 2019. I mean, that's an acceptable method. However, people had some doubts earlier, especially the teachers, school teachers had some doubts. Okay, let me tell you what it is. No, not that. No, not in 28, 19. Probably the first paper question. Anyway, but okay. Now this how you have to do it. Huh? Now cos 5x is equal to this. Now you treat this as a like a particular solution, no special solution, like alpha. Like when you have say cos theta is equal to cos alpha, you can write this as theta is equal to n pi, sorry, 2 n pi plus or minus alpha. So you do the same thing with this, right? 5x is equal to 2 n pi plus or minus. I mean, this one is easy, right? Sin x is sin 0. So you can write x as n pi plus minus 1 to the power n times 0. So x is n pi. Now here, I'll use m or something. N and m are integers. Now you have to make x the subject. Now how do you do that? If it is positive, this is what? Minus 3x. So if you take it to the other side, it will be 8x is equal to 2m5 plus 5 by 2. If it is negative, right, it will make it plus 3x. So if you bring it to the other side, it will appear as 2x. Here you have 2m pi minus 5 by 2. Now divided by 8. Okay, I'll take this example. Take this for example, sin x is equal to cos x. Right? We can just find the solutions like sin x goes like this, cos x. This one solution, this another solution. These are the solutions. Pi by 4. This after pi, so you get 5 pi by 4. Then you get hold on. Sine goes like this, right? This is 360. After that, 9 pi by 4. These are solutions. Now I'll do it in this way and show you how you get this sin x. You can write this as sin 90 minus x. Now both are sine functions. So treat this as this special solution like alpha, and you get n pi plus minus 1 to the power n pi by 2 minus x. Now you have to make x the subject. Now this is minus 1 to the power n and minus x. So if you bring that term to this side, you get x plus minus 1 to the power n x. This side you have n pi plus, this product is there, pi by 2, right? Now you can make x the subject like this. Yeah, I'll pull out pi, you get n plus minus 1 to the power n times half. I'll divide this by this. Huh? So x is this. But you get these values in a weird way, but still you get the same. Because otherwise we are not sure whether, how you get those solutions using this method. By this method. We'll see. Now, if you plug in values for n, you will end up with these results. Now say n is 1, sorry, n is 0. So these go on to 0, minus 1 to the power 0 is 1. So this half. divided by, when n is 1, sorry, n is 0, initially we took n as 0, so minus 1 to the power 0 is also 1. So 1 plus 1 is 2. You get pi by 4. When n is 1, this is 1. This is also, sorry, this is 1. Minus 1 to the power 1 is minus 1. So you get pi times 1 minus 1 over 2. Here you get 1. When you plug in 1, you get minus 1 to the power 1 is minus 1. So that doesn't exist. Right? So this valid only if n is even, not for odd values of n. Why? If you plug in 1 there, minus 1 to the power 1 is minus 1. So this will be 0. So it is true for only even values of n. So we'll go for 2. Now n is 2. Minus 1 to the power 2 is 1. So it is half divided by minus 1 to the power 2 is 1. So 1 plus 1. This is 5 over 2 divided by another 2. That. So you get this. I'll go for one more. If you plug in 4, this is 4. Minus 1 to the power 4 is 1. So 4 plus half divided by 1 plus 1. 2. This is 9 over 2 divided by 2. Like that, the expression looks weird, but still that contains the same set of solutions. And that's, in a situation like this, that's how you have to solve it. It's kind of difficult. This is also kind of difficult. Compared to the normal inequalities containing modulus functions. This is not difficult, but here you have to come up with a useful substitution. Right. Then we have problem on vectors. We'll leave it for the time being. Today we'll concentrate on few method stuff today. Next day, we have only one problem from vectors and coplanar forces. We'll pay more attention to that next time. Right. So in the second paper, we'll take the fifth. So compared to normal paper, like this can be considered as a difficult paper. The actual paper will be a little more easier than this. Right. Now, we have to show that, okay, fx is a quadratic function. A is less than 0. We have to show that fx is a times something. So we have to use the completing. We can do it by completing a square. You pull out a, then complete a square. The square root of this is x. Right? Then you divide this by 2. Now, if you do that, this will contain three terms. The x squared will be there, and 2ab term is this, and the square of this was not in the previous step earlier. So you have to subtract that. The square is b squared over 4a squared. You have to subtract that. The extra term introduced by completing a square should be subtracted. Right? Now we have to simplify that part. You can take the common denominator, then this should be multiplied by 4a. Now we'll expand this. I mean, eliminate the bracket. This a will go away with one of these a's. So it will be like this. This is in fact delta. B squared minus 4ac is minus delta. Because if you pull out minus sign, it will be b squared minus 4ac. No, I have to keep this a as a factor. So this will be a squared. Sorry. Now we have to show that this is a minimum. Hence find the minimum value of ax squared plus bx plus c. Right. For the real values of x, right? We know that the perfect square is greater than or equal to 0. Now you I mean, even though we are supposed to do it like this, we better expand it in this fashion. No? Then when you multiply this, you get delta over 4a. Now, we'll try to rearrange the left-hand side so that we get something like this. So we'll multiply both sides by a. Is still 0. Hold on. Now look, a is negative. So you cannot do it like this. Since a is negative, when you multiply an inequality by a negative number, the inequality should be reversed. If a is positive, you can keep it intact. But in this case, you have to reverse the inequality. Now add this. You can add something to both sides. Now, this is fx. So it's always less than or equal to some number. Say this is 5, just for the sake of explaining this. So this is 5. So fx is always less than or equal to 5. So fx can attain 4, 3, 2, 1, minus 10. So this is the maximum value of this. Therefore, if you have this inequality, what you can claim is that I write f max. The maximum value of fx is minus delta over 4a. It doesn't mean that f max is negative because a is negative. If delta is positive, this number is positive. Right. Right. Now, the value of fx, sorry, the maximum value of fx is attained at x equals 2. So it means that the maximum value occurs at this point. Look, for the maximum value, the equal sign should be there. This equal, but this should be equal. So this equal. This is equal to 0. This is equal to 0 when the bracket is 0 inside what is sitting inside is 0. Therefore, when this bracket is 0, means what? X should be equal to minus b over 2a. And this says that x is 2. So you can come up with some relationship. Say 4a is minus b. We have to come up with 3 such relationships to find a, b, and c. And we have to show that fx is something. Fx is, okay. Now fx is ax squared plus bx plus c. The maximum value is given as 10. I didn't see that. Huh? It occurs at x is equal to 2, but f max is 10. Now, if max can be obtained using this. And finally, we have to prove that, we have to show that fx is something like this. Ax squared minus 4ax plus 4a plus 10. That means you have to eliminate b and c, both b and c. Now, b is 4a, right? I'll change it to like b is minus 4a, right? On the other hand, you have to eliminate c. To do that, you have to use this, f max. Now, f max is minus delta over 4a, means what? Minus b squared minus 4ac over 4a. I'll erase this. Huh? I just want to show you what motivates us to obtain the answer. First, you have to eliminate b in terms of a. Now, find c in terms of a. Now, if max is 10, this is b squared minus 4ac over 4a. Now, b squared is what? Using this, you can write it as minus 4a quantity squared, which is 16a squared minus 4ac over 4a. Now, 1a will go away, right? You can divide each and every term by a. And at the same time, you can divide each and every term by 4. So you have minus, this will be 4a, right? This will be c. If you divide this by 4, you get c. So finally, this is what you have. 10 is equal to minus 4a plus c. Minus 4a plus c. So c is 4a plus 10. Now from 1 and 2, you can rewrite fx in this way. This is fx. Now b is minus 4a. C is 4a plus 10. Right? Right. Now, for a, if a is between these two values, we need to show that 1 is not a root of fx is equal to 0. 1 is not a root. We'll substitute 1 and see what happens. If you want to show that 1 is not a root, you have to go for the method of contradiction. So assuming that, okay. If 1 is a root, it should satisfy this equation. So A minus 4A times 1 plus 4A plus 1. These two will go away. You have A squared plus 1 is equal to 0. But this doesn't, no matter what the value of A is, 1 is not a root of this equation because A squared plus 1 cannot be 0, right? So 1 is not a root anyway. Even without this condition, it is true. No matter what the range is, A squared is greater than 0, greater than or equal to 0. So A squared plus 1 is greater than 0. So this is a contradiction. This one. Huh? Well, we can claim it like this. This is a contradiction since blah, blah, blah. We can say it like that. Even though it is not in this interval, still the case is true. 1 cannot be a root of this equation. Hold on. This 10. So A squared plus 10 is greater than or equal to 10, and clearly it is greater than 0. So it cannot be equal to 0, right? Now, if the roots of fx is 0 are alpha and beta, find alpha plus beta, right? And alpha beta, you have to find both anyway. Now, this is the equation we have. If the roots are alpha and beta, alpha plus beta is minus of this divided by A. So it is 4 alpha beta. 4A plus 10 divided by A. Now we need to find 1 minus alpha times 1 minus beta. So if you multiply, you get 1 minus beta minus alpha plus alpha beta. Alpha plus beta is 4. Alpha beta is 4A plus 10 over A. You can take A as the common denominator. You have minus 3A plus 4A plus 10. So A plus 10. So find the quadratic equation with roots alpha over 1 minus alpha and beta over 1 minus beta is this. Here you get sum of the roots. Now take the common denominator here. If you multiply, you get alpha minus alpha beta, beta minus alpha beta. You can multiply each and every term by 1 minus alpha times 1 minus beta. You get that. Here you have alpha plus beta minus 2 alpha beta. Here you have alpha beta. You substitute these values. This is A plus 10 over A, then you can simplify that. Alpha plus beta is 4. Alpha beta, 4A plus 10 over A. Alpha beta is 4A plus 10 over A. Then you can multiply everything by A. You get A plus 10 x squared. Here you get 4A. 4A minus 8A minus 20. 4A minus 8A minus 4A minus 20. Everything will be positive. You have 4A plus 10. Something like that. Relatively, it's difficult, more difficult than a regular problem from quadratic equations. B. Okay, x plus 2 is a twice repetitive factor of fx. So fx should be something like this. X plus 2 squared is there. Here something is missing. The degree of fx is missing. I think it's a cubic, should be a cubic. That's missing, huh? Yeah, fx should be a cubic polynomial. I'm sorry about it. Fx should be a cubic polynomial. When okay, x plus 2 is a twice repetitive factor of fx. Now, if it's cubic, huh? Sorry about it. I shouldn't use g here. But g is used somewhere else. I'll try to take it as hx. Now, since fx is cubic, this is already like this contains x squared. To have a cube, you need to have something like ax plus b, a factor like this, right? Otherwise, it cannot be a cubic polynomial. Now, you need to figure out a and b. If you try to, like, even if it's given as fx a cubic polynomial, don't take it like this. If you do it, in most places, it is taught like this. But if you try to do it, you have to find 4 constants. Means you need to come up with 4 simultaneous equations. But if you use this data, you need to compute only 2. Now, it's given that when fx is divided by x times x plus 1, the remainder is 5x plus 4. I'll take this as mx. So by division algorithm, you can write fx like this. This is the divisor times mx plus 5x plus 4. Now we don't need to find this unnecessary polynomial. Now fx is this. Somehow we need to compute a and b. We need to compute a and b. So to compute a and b, we have to get rid of mx because we don't want to find mx. Then substitute two values for x, like two values. Substitute 0 and then substitute -1. When x is 0, this is b. When you substitute 0, you get 2 squared. This 0, this also 0, you get 4. So b is 1. Now substitute x is equal to -1 because which in turn make this factor 0. So if you plug in -1, this is minus a plus b. When you plug in -1, -1 plus 2 is 1. So 1 squared is 1. When you plug in -1, this entire thing will be 0. When you plug in -1, this is 5 minus 4 plus, sorry, -5 plus 4. B is 1. So minus a plus 1 is equal to -1. So a is 2. So it is 2x plus 1. Then if you multiply this by 1, you get this. So this is fx. Now if gx is x times x plus 2, obtain the partial fractions of 1 over, now don't write it like this. Do it in this way. 2x plus 1 times x plus 2 quantity squared. This is x times x plus 2. Now look, this is what you get. You can pull out x plus 2 quantity squared. You are left with 2x plus 1 plus x squared. That obtain the partial fractions of this. So there are two ways of doing it. Okay. Now there are two ways of doing it. Now, since you have a square, you have to start from x plus 1 for this. Then you have to find 4 constants. But there's another way of doing it. Without finding even one constant, you can obtain the partial fractions of this. This is a shortcut. I mean, you can do it like this anyway. Don't get the partial fractions of this. Just get the square root. I mean, both are squares, right? In that event, you can just take this. Now, since both of them are like simple factors, you can subtract the smaller one from the larger one. Sometimes you may get a constant, but in this particular case, you just get 1 because x plus 2 minus x plus 1 is just 1. So it is exactly equal to this. Both are equal, right? But say, for example, if you have 3, then 1 is not equal to this 2. Therefore, to make it equal, you have to divide it by 2 in this case. But in the given problem, since you have 2, you don't need an extra constant. Both sides are equal. Now divide. When you divide this by what is sitting downstairs, you have this. Right? Now this is what you have. Now square both sides. When you square, you exactly get this. Right? This is a kind of a shortcut method. No? This also square. 1 squared is 1. Now you know it is like a minus b quantity squared. You square this, then you square that. Then the term in the middle, what is it? 2 times this, but you have a minus sign. Right? Now you can pull out minus 2. What is this? This 1 over this 1 over x plus 1 times x plus 2. You have it right there. 1 over x plus 1 times x plus 2 can be expressed as partial fractions like this. So from 1, this is simply 1 over x plus 1. So you have 4 constants computed, but without actually computing the constants. You can possibly do it like that. But I didn't realize that everything is more difficult than the expected like problems. Huh? Clearly, you can do it like this. I mean, but it's little, time taking. Sorry, a little more painstaking. You have to find four constants. Either you can substitute values so you can compare coefficients, but it takes time, more time, and it needs more work. Now we'll consider 7a. We'll consider problems pertaining to vectors and coplanar forces next time. Okay. Right. Now, x-intercepts are 0, 0. Some data are given. I mean, we had something similar to this, not exactly the same. I think 22, 23. In those 2 years, few newcomers came to the panel. When newcomers sent papers, it turns out to be, I mean, they include difficult problems. Now, x-intercepts are 0, 0 and 1, 0. And x equals 3 is a vertical asymptote. That means at x equals 3, the function is not defined. A should be 3. And on the other hand, this says when x goes to infinity, we can even start with that. With that, you can find capital A. A is 3, right? Because at A equals 3, the function is not defined. Simply is 3. Clearly, it is 3 using this. Now, we'll go for this. When x goes to infinity, fx should go to 0. Sorry, fx should go to 1. We'll divide both upstairs and downstairs by x squared. Here, by dividing the inside by x, we are actually dividing it by x squared. I divide both factors by x, each factor by x. That means we are actually dividing upstairs by x as well. As x goes to infinity, now if x goes to what value? This is 0, 0, 0. So you get 1, 1, 1, but there will be an a sitting outside. But it says that a is equal to 1. Look. Therefore, you can now write fx like this. X minus b, x minus c over x minus 3, quantity squared. Because simple A is 3, capital A is 1. Now we are in a little better shape now. This says that when x is 1, y is 0. Now we'll go for this. So if x is y, 0 is equal to 0 minus b, 0 minus c. I mean, we don't have to go through these things. There are two word, I mean, are excess asymptotes. Right? When x is 1, y is 0. When x is 0, y is 0. Y means fx. You can take it as y. So what are the values of b and c? When x is 0, if you want, you can plug in 0, this is 0. Right? If this is 0, the upstairs should be 0. So, I mean, what are the two values of b and c? You know, y is 0. Look, when x is either 0 or 1, right? That means what? You need to have a factor like this. One factor in the upstairs should be x. The other is x minus 1. You don't have to, I mean, clearly find b and c. So b and c are zero and 1. However, not respectively. We cannot exactly say that b is 0 and c is 1 irrespectively. But it doesn't do any harm because x minus b times x minus c is equal to x minus c times x minus b. So it doesn't matter. So now finally you can claim this as fx, x times x minus 1 over x minus 3 quantity squared. Now we have to differentiate. Now we know everything, huh? We know the axis intercepts, asymptotes and everything. I mean, you can differentiate this. You will end up with this. Oh, anyway, I'll do that. This will be squared. Right. Now, when you differentiate this, you get x times the derivative of that is 1, then x minus 1 times the derivative of x, which is 1. You get 2 times x minus 3. You can divide everything by x minus 3 because x is not equal to 3. Now you can simplify. Then you have minus 6 minus 6x minus 7x plus 3 minus 2x squared plus 2x. So you have 3 minus 5x. There's a little mistake there. The extra negative sign shouldn't be there. Now we need to sketch the graph. Hmm. Right. Now we have to find the stationary points. We know the rest. We know the x-intercepts and vertical asymptote and everything, right? We need to find the stationary points. So the upstairs should be equal to 0. You have to find the y coordinate. You know, this is the function. Huh? X is 5 over 3. 5 over 3. So x is 5 over 3. This is x minus 1. Then this is x minus 3 squared, right? Yeah. If you take 3 as the common denominator, you get 2 over 3. This is 9. So minus 4 over 3, quantity squared. 10 over 16. The 3 squared will go away, which is 5 over 8. Now we'll sketch. When x is very large, this is positive, though the upstairs is negative. Therefore, the entire thing is negative. When you cross this over, 3 is there because of this factor. It's a cube. Therefore, the sign is changed because the power is odd. This is positive. Again, when you cross this over, it is there because of this factor. Again, the sign is changed. So it is decreasing. 0 should be somewhere here. So I'll draw the y-axis there. Now the asymptotes. Vertical asymptotes is here. The horizontal asymptote is this. It is at 1. 0, 0 and 1, 0 are x-intercepts. And there's a minimum here, minimum or maximum, whatever, at this point. 8 over 5. 8 over 5. Hold on. This is 3 over 5. I have plugged in 5 over 3, so it's wrong. Huh? 3 over 5. So this is, now if you take this, you get minus 2 over 5. This is 3 minus 15. 3 minus 15 is minus 12. Now it is not that fun. This is what you get. 3 times minus 2 is minus 6. Downstairs you get 12 squared, 144. Minus 1 or 24. Is that correct? We'll see. Minus 2, 5, that's fine. Yeah. So these two will go away. I mean, 5 squared will 5. will go with the 5 squared sitting in the downstairs of the downstairs. So you get that. So it is somewhere here. A small negative value. Now it is decreasing throughout up to this point. Then it is increasing. It is decreasing. Now we need to sketch one graph and we need to solve an equation. Now we need to sketch f of x plus 1. If you are not sure what to do, take something like this, x squared. Now what is the graph of y equals x plus 1 quantity squared? Again, it's a parabola and it is 0 when x is minus 1. So what happens is, if you replace x by x plus 1, the graph shifts 1 unit to the left-hand side, other way around. So the graph of f of x plus 1 will be something like this. The asymptote will move to 2. Because if you plug in x plus 1 there, x plus 1 minus 3 in the downstairs will give you x minus 2. So the asymptote will be at 2. The intercepts 0, 0, the intercept at 0, 0 will move to this. Intercept at 1, 0 will move to this point. Nothing will happen to the horizontal asymptote. It will be like this. Now we have to solve this. Now we don't know what to do with that. We have a little doubt because we have this. Now there are 3 cases. We can consider 3 cases. When fx is greater than 0, when fx is equal to 0, when fx is less than 0. When fx is greater than 0, no matter what it is, fx is just fx. Now, mod fx is, when fx is greater than 0, it is just fx. So it will be 2fx. When fx is 0, this is 0, this is 0. So it is just 0. When fx is negative, fx is still fx. However, mod fx is minus fx. So that is also 0. So means this is 2fx. 0 when fx is 0. When fx is less than 0, still it is 0. So when you solve this equation, it is if it is greater than 0. Now this is greater than 0 only if you are in this interval, because otherwise it is 0. You have to solve it when this sum is greater than 0. In these two cases, the sum is equal to 0. Here it is greater than 0 because fx is positive. So you have to choose the interval for which fx is positive. So here, this interval plus this interval without 3, because at 3 the function is not defined. So that solution, I'll write it here. From minus infinity to 0, right? Fx is positive. So you are here. That means this sum is greater than 0. From minus infinity to 0, excluding 0, because at 0 it is 0. Then remove this part. Then 1 to 3, 3 to infinity. This is the solution to that. Hold on. Right. I mean, when I'm doing these problems, I feel like every problem is very difficult, but each, I mean, every time you don't get similar problems in one paper, right? For example, something like this, that Modulus, this was there in one paper, I think in 22, 23. Uh, once you sketch this graph, sketching f of x plus 1 was in one paper, but you don't see everything in every paper, right? For example, in 7 part A, you need to figure out those unknown constants. Only once there was a problem like that, but you don't see all these difficult problems in one paper. Right. Now we do 8. 7 part B is not a big deal. You can do it. We have done similar problems in the class as well. Okay. I'll start with part B. This says that in usual notation, you have to state the cosine rule for a triangle ABC. You know, there are 3 results. It is like Pythagoras theorem. For this, you get b squared plus c squared. For b squared, you get a squared plus c squared. For c squared, you get a squared plus b squared. Then it is like b minus c quantity squared. You get 2bc. Here you get 2ac. Now, there's no reason for this to be called as a cosine rule, because cosine is not there. Now, cosine comes at last. This is cosine A, the same thing. Now, we need to show that A plus B quantity squared, sine squared C over 2, plus A minus B quantity squared, cosine squared C over 2 is C squared. We have to prove this. Now, how would you do this? The line of thinking should be like this, okay? Now, there are 3 results. 1, 2, 3. Okay, we'll think together. 1, 2, 3. Okay, which one would you choose to prove this? 1, 2, or 3? Because here you have c squared, right? Which one would you choose? 3. Here you have c squared as the subject. So we can start here from this. Now, on the other hand, look, if we expand this, every term carries either sine squared or cosine squared, every term, right? Because there are 3 terms carrying sine squared, because look, if you expand this, you get a squared plus b squared minus 2ab. Here you have a squared, plus 2ab. Here you have a squared plus b squared minus 2ab. So every 3 of them contains sine, the other 3 contains cosine, right? So, okay. And every angle is c over 2. C over 2. Now, what should you do? You have to replace this guy by c over 2. But if you have just cosine c over 2, you know what to do. Cos 2 theta is 2 cosine squared minus 1. Right? You can use that. That's another formula. 1 minus sine squared theta. But you cannot use either of them. Why? here you need to have both cosine and sine. Therefore, you have to go for this. You have to go for this. Right? So we'll start with that. CO2. Now, on the other hand, I came up with another idea. Look, every term in the left-hand side of this should contain either cosine or sine. Now, this part is taken care of, right? That's fine. What about this? We cannot leave this alone. It should contain both sine and cosine. Otherwise, you cannot prove this. What should you do? How do you incorporate cosine sine here? Can you write one? Now you can write this as one, right? How can you write one in terms of cosine and sine? And at the same time, wherever you have cosine, it will be a square. Wherever you have sine, it will be a square. So you can write it like this. How do you write one in terms of cosine and sine? You can write it as cosine squared plus sine squared. Use the same angle. Right? Because that's how you have to, that's the line of thinking should be like that. Because you need to use, rather than using A and B, you have to use, 1 and 2, you have to use the third one. And on the other hand, if you observe, if you scrutinize this, you can see that every term has either cosine squared or sine squared. Clearly, cos can be transformed into something like this. So what about this? This should contain some cosine and sine terms. So take it as this times 1. 1 can be replaced like that. Now collect the terms containing sine squared. Okay, what are the terms containing sine squared? Sine squared times this. You have a squared plus b squared. And there's another term here. It is minus 2ab times minus 1. So it is plus 2ab. What about the terms containing this cosine? Here you have a plus a squared plus b squared times this minus 2ab. So this is a plus b quantity squared. Right? That's it. So this is squared. Now you need to find something. When A is 10 and B is 5 and C is tan inverse half, find C and A. Oh, that's not a big deal. We have to tan, C is given as tan inverse half. So you need to find cosine and sine. Now tan C is half. This is square root 5. You see it's a acute angle because tan C, inverse is given, C is given in terms of an inverse. So it should be an acute angle. You have to find C. So cos C is 2 over square root 5. it doesn't turn out to be very nice. That's why I'm looking. A and B are given, so you can find C from this. I'm not sure whether this is C over 2. Tan inverse half. Yeah, we'll use it. Just hold on, 1 second. Uh, I think it should be C over 2. Otherwise, you get a nasty answer. I'll change it to C over 2. Yeah, we'll do it like that. Otherwise, no point of obtaining this expression. Should be C over 2. So you can find, okay, CO2 is an acute angle, clearly. Because C should be less than 180 anyway. So you can find sine C over 2, which is 1 over square root 5, cos C over 2, 2 over square root 5. Then we'll substitute those here. C squared is, AB are given, A is 10, B is 5, I guess. A is 10, B is 5, yeah. So we'll use this. Now, A is 10, B is 5. Sine squared is, okay, sine C over 2 is this. So sine squared C over 2 is 1 over 5. Some factors will go away. So that makes sense. A minus B, 10 minus 5, quantity squared. Cosine squared. Cosine is 2 over square root 5. So it is 4 over 5. Now this is 15. 15 squared is 25. This is 5. So 25 times 4 over 5. This is 45. This is 5 plus 4. Sorry, 5 times 4, 20. So it's not that bad. C is square root of 65. Now we need to find A. We'll apply this. This way you have cosine. Now we know all the three sides. So it's not a big deal for us to find cosine. A is 10, B is 5, C is square root of 65. So this should be 65. 2 times 5 times square root 65 cos A. So let's bring that to this side. 90 minus 100 minus 10. So cos A is minus 1 over square root 65. I mean, you can have something like that. Means the angle is greater than 90. If you have a negative, inverse of a negative, cosine inverse of a negative value, it is 5 minus cosine inverse 1 over square root 65. This is a small value. This is almost 90, say 85. So 180 minus 85, like 95. It is slightly greater than 90. Right. B is the smallest triangle. Since I give you the paper on Wednesday, you don't have enough time to complete it by Friday. Probably next time we'll delay the discussion by 1 week, right, or something like that. After that, you have enough time to go through that. We'll do part C. Part A is easy. You can just apply sine A plus B to find sine 75. Okay, now you can take this as alpha. So alpha is this, so tan alpha is 1 over x plus 1. Now since, if you write this as alpha plus beta is equal to gamma, you can take tan of both sides. This side you get tan alpha plus tan beta over now we'll plug in these values, these expressions. Tan alpha is 1 over x plus 1. This 1 over x plus 3. This side you get 1 over 2 times x plus 2. Now we can multiply, I can take everything to one side, but first we have to multiply each and every Because x cannot be equal to -1. Nah? This doesn't exist otherwise. X is not equal to -3. You can multiply everything by x plus 1 times x plus 3, the left hand side. You get x plus 3 is x plus 1. This will be multiplied by x plus 1 times x plus 3 minus 1. This is 2x plus 4, means 2 times x plus 2. This is x squared plus 4x plus 3 minus 1. So plus 2. Now bring that guy to this side. Don't cross multiply because we don't know that this may be a root of the equation. Therefore, bring everything to one side. Otherwise, you have to give all the conditions when you multiply, cross multiply. Now we can take the common denominator and simplify. Since it's a rational function, the upstairs should be equal to 0. These two will go like this 4 times. Here you get x squared plus 4x plus 2. Therefore, the upstairs should be equal to 0. So you get 3x squared, 16x minus 4x means plus 12x. 16 minus 2. So 3 times 14. Factor it's hard to factor. Therefore, we can use, the quadratic formula. So minus b plus or minus b squared minus 4ac. Oh boy. You get complex roots. See, hold on. We have to check whether this is correct. It's wrong. At the beginning, I have made a mistake. This should be minus. I wrote plus there. It should be minus. We'll correct it here. Minus plus. Is minus. It's not that bad. So you get this. Upstairs, you get x minus x 0. 3 minus 1 is 2. Here you get x squared plus 4x plus 3 plus 1. 4. Which is in fact x plus 2 quantity squared. That's much nicer than what we got. Now it's not a big deal. We'll take the common denominator. Now here this is multiplied by 2. So upstairs is multiplied by 2 as well. Here this is multiplied by x plus 2 in the downstairs. So this is 2 minus x. X is 2. Now, if you plug in 2, since 2 is the solution, you can write it here. X is 2. Okay, we have to find sine of tan inverse 1/3 plus tan inverse 1/8. That is not possible, right? Look, it should be like this. We have to find this, right? Otherwise, we cannot use this relationship. So bring that tan inverse 1/8 to this side. It is tan inverse 1/5. Draw a triangle. Let that angle be alpha. So 1/5 means this is 1, this is 5, this is square root of 26. Right? Now, let this be alpha. No, don't take it as alpha. Tan inverse 1/5 was taken. No, we'll use some other angle. That's better. Delta. Now we'll take sine of this. Sine delta. We have to make sure that this is between 0 and 90. We have to state that. Otherwise, you cannot draw a triangle. Clearly, inverse function is defined here, therefore it should be an acute angle. But you have to mention that whenever you draw a triangle to compute another angle. Now, sine of this. Sine delta. You know what is sine delta is? Opposite to adjacent, opposite to hypotenuse. 1 over square root 26. Right? Yeah. We are left with part A. Just give me 5 to 3 minutes. Huh? I'll be back. Okay. First we have to, okay, in part A, we have to find sine 75. Just apply sine A plus B. Now if you take A as 45 and B as 30, this is square root 3 over 2, this half. So you can take the common denominator as 2 square root 2. Now you need 4 in the downstairs. So multiply both upstairs and downstairs by square root 2. So it will be 4, right? 2 times square root 2 times square root 2. Like this. So upstairs you get square root 6 plus square root 2. Then we have to find this. We can start with the right hand side. Which is tan 45. We'll apply the formula tan A plus tan B over 1 minus tan A tan B. Then you need to square it. So this is 1. Both upstairs and downstairs are squared separately. This is 1. Now you can multiply both both upstairs and downstairs by cosine square theta over 2. So in that event, this would be, yeah, like inside, like if you bring that inside, it will appear as cos theta over 2. This will be sine theta over 2 because these two will go away. This theta over 2. Now if you expand it, you get cosine square theta over 2 plus sine square theta over 2 plus 2 times like 2ab term. Downstairs you have the same. But the term in the middle is minus. So this is 1. That is sine theta. Because 2 sine theta over 2 cos theta over 2. Right? 2 sine A cos, 2 sine theta cos theta. I mean 2 sine A cos A is sine 2A. So you get this. Now we need to find tan pi by 24. Tan pi by 24. So we have to go for this. 45 is pi by 4 plus theta over 2 should be pi by 24. I mean, you have to choose theta so that you get, choose theta such that for that particular value, you get pi by 24 in the oh sorry, tan square should be here, in the angle. So if you find this, so 24 is the common denominator. So theta is 2 times minus 5 pi over 24. That is 75. So we have to choose minus 75 for theta. Minus 75 O minus this. This becomes like minus 5 pi over 12, but it is divided by 2. 1 plus sine 24. That is, sorry, theta should be 12. Minus pi, sorry, 5 pi over 12. We know that sine minus theta is minus sine theta. That is 75 in degrees. So we'll plug in those, the expression we have computed earlier. You can multiply both upstairs and downstairs by 4. This tan squared. That angle will be pi by 4, right? That's how we have computed it. This plus theta over 2 is pi by 4. Sorry, pi by 24. Why worry too much? We'll take the square root. Right? You can find it like that. Okay. This time the problems were very hard. Hard means when I go through that, I felt I mean, sometimes we had problems similar to this, but not in one paper. Right. The actual paper is much more easier than this, right? Because if you set a paper like this in the final exam, the setters of the paper will be in trouble. Your explanation then you know, කරන්න 2009 or somewhere closer to 2010, that happened. Because pass rate has declined to 25%. So I put them. It had happened due to some retirements. So three resigned from the panel. Therefore, some newcomers came to the panel and they came up with difficult problems. Usually, like if I give you give a chance for you to like design or devise a problem, always it will be extremely difficult because that's your first time preparing a like question. දරුවොත් ඔක්කොම වැඩ දාලා තමයි ක්වෙස්චන් එක හදන්නේ. අලුත් කෙනෙක් එහෙමයි. හැබැයි ටිකක් කල් ගියා මේක වෙනස් වෙනවා. එහෙනම් පේපර් එකේ සාමාන්‍යයෙන් difficult problems එනවා අඩුයි. I mean, not sometimes you may get, like, say, in the first paper, you may get 2 challenging problems, but the other it are easy. Like that. In the second paper, probably out of 7, you may get 2 difficult problems. So it's up to you to skip those. You can skip කරලා පුළුවන්. This is little difficult. So don't think that your aerial paper will be something like this. It will be much more easier than that, and it's much more easier than the term test papers as well. Term test වලත් difficult problems හොනවා. අනික term test වල හොනවා එන්නේ නැතිව. Like this logarithms එනවා. ඊට පස්සේ modulus functions දෙනවා algebraic method එකෙන් හදන්න. ඒක එන්නේ නැහැ. හරි. ඊට පස්සේ දෙනවා මොකද්ද domain codomain ඒවා. ඊට පස්සේ දෙනවා rigid body. Like rigid body was an integral part before 2000, right? With mechatronics and stuff like that, now rigid equilibrium of rigid bodies doesn't play a vital role in engineering. Therefore, now it is there in the paper as the 7th problem of applied. So 1.25 marks තමයි හම්බෙන්නේ එකට. Now term test එකේ දෙනවා ප්‍රශ්න 4ක් ලොකු ඒවා. කියන්නේ nearly 50%. ඒ කියන්නේ term test එකේ weight එක nearly, I mean, 30 to 50% වෙනකන් ඒකේ problems දෙනවා සමහර විට. But actual representation of that section in the final paper is like 1.25 marks. ඒකට ඕනෙන් පොඩි geometric results දෙයක් විතරයි. Midpoint theorem and the the angle subtended by the diameter on the circumference, which is 90. ඒ දෙක විතරයි ඕනේ. ඒක තිබුණා නිකන් හදන්න පුළුවන් පොඩි problems තියෙන්නේ. Right. Now those days, rigid body, equilibrium of rigid body, we had very nice problems. So still people like to include those in the term test, but you don't get problems from that anymore. එහෙම තියෙනවා. හැබැයි මේ problems ඔක්කොම paper එකේ එනවා. They are very similar to the problems in the paper, but all of them are difficult. That I have to agree. Right? ඒවා එන්න පුළුවන්, but not in one paper. Like if you get something like that for the graph, the problem we discussed today, you don't get something like that in the other problems. You would get there, I mean, easy problems for them. And on the other hand, the quadratic equation, for example, that's also difficult. Right? ඒකවොත් අනිත්‍යව එහෙම අමාරු වෙන්නේ නැහැ. It's like that. You may get one couple of difficult problems, but not everything. එහෙමත් හදන්න බෑ. Now you are probably best of the best. ඒතකොට දැන් ඕගලන්ටත් බැලන අනිත්‍යර කොහොමද බෑනේ. Right? At least we should pass nearly 60% of the students. At least. We should give at least, which means island-wide, at least 5 to 6 A's. So definitely you should be among them. 75 score කරන්න පුළුවන් වෙන්න ඕන. This paper is relatively, I mean, comparatively difficult, but that's okay. You learned a lot of stuff from this, but you don't get a paper like this in the final exam. Right? Most problems will be easier. Some of them are difficult. Only few of them. And without touching those difficult problems, still you can secure an A if you don't make careless mistakes. Without it. But you can still, if with the enormous strength, you can still get a C if you try to get stuck in one problem. Then so just ignore it and move on. Don't stay there. ඔයගොල්ලෝ දන්නේ problem එක හිර වෙලා ඉන්නකොට වෙලා වෙනවා දැනෙන්නේ නැහැ. ඒක ඉන්න ඉතල try කරලා ඊට පස්සේ ගත්තම ගොඩක් වෙලා කියලා හැබැයි you haven't scored anything. Right? ඒක අපරාධයි. Don't get stuck. If you don't get something, skip it and move to the next one. Leave some space for the problem and move on. Don't stay. And the second is don't make careless mistakes. With those two, with the talent you have, you can still, I mean, straight away get an A. Mistakes are සාමාන්‍යයෙන් because sometimes you may skip a problem, part of a problem, or you may read the diameter as a radius. Even on, in particular, single videos, Ardha Vishkambe, Kiva Vishkambe Girano. Ardha Vishkambe means radius, right? They take it as a Vishkambe, which is diameter. Even on, uh, another thing is that probably the weight of a rod is given. Sometimes it's given as a unit, like unit weight. I mean, unit weight means for a particular length, this is the weight. You may mistakenly take it as a weight. Right? Those are the mistakes people might make. Probably you might miss some constants, like instead of 2a, you take it as a. That's good enough for the mistake, right? So don't make those mistakes, then you will be in a good shape if you don't make mistakes, and at the same time, don't get stuck in a problem in the paper, in actual setup. එහෙමනොත් ඒකේ හිර වෙලා ගොඩක් වෙලා හිටියොත් ඔයගොල්ලෝ දන්නේ වෙලාව යනවා. පස්සේ ඔව් රස කරන්න දෙන්නේ වෙලාව නවත්තන්න බෑනේ. ඒතකොට යනවා වැඩි. එහෙම කරන්න එපා. බය වෙන්නත් එපා. අනික don't get scared. Like say for example, say after 2 hours, right? After 2 hours, say you are done with 3 problems in the second paper, and say 4 problems in the first paper. Sorry, 4. Now you have to do 2 problems in the second paper and 6 in the first paper. So clearly with this rate, you cannot do it. If you go for the next hour, third hour, it should be like 1.5 problems here and 2 problems here. Right? Still, it is not that bad. Because if everything is right, this is like 67.5 marks, and this is like 15. Right? So you are heading to 82.5 with the rate, with this rate. You're not going to, then we get only 4.5, you get 15, you get 67.5. For this, you get 15. So you're heading towards 82. What happens is, if you extrapolate this, look, wow, man, I have to do 2 big, long problems and 6 first paper problems. So for this, you get 54 minutes plus like 4.5 times 6, 78 minutes. Now, I need 78 minutes, but I am left with 1 hour. So you get stuck, you get scared. I mean, you get panic. You panic, basically. When you panic, what happens is that, we are not a species to, designed or evolved to write exams. අපි exams ලියන්න කොච්චර කාලෙ නැත්තම් අපිත් exam ලියුවේ නැහැ නේ කාලේ. අපි ගිහිල්ලා exam ලියුවට we didn't care the outcome of the exam. අපේ කාලේ එහෙම care කරේ නැහැ. Probably 10 years ඇති වුණා. Exam සිරවට කරන්න පටන් ගන්න 20 years කියන්නු. 20 years. ඒකට evolve වෙන්න කල නැහැ. generation නිකම් 100ක් විතර ගිහිල්ලා ඔන්න වෙද්දි ඒක evolve වෙලා තියෙයි. තාම evolve වෙන්න ඒක not we don't have enough time for that. එතකොට වෙන්නේ මොකද්ද? panic වුණාම මොකද්ද වෙන්නේ? Either you have to fight or flight. එක ෆයිට් කරන්න එක දුවන්න ඕනනේ. ඒතර මොකද්ද වෙන්නේ එහෙම වුණාම? ඒතර අපිට එනර්ජි එන්නේ, ඒ කියන්නේ අපේ බ්ලඩ් සර්කියුලේෂන් එක වැඩි වෙන්නේ මසල්ස් වලට, අත් වලටයි කකුල් වලටයි. පැනික් වුණාම මොළයට ලේ යන්නේ නැහැ. ඒතකොට බ්ලැන්ක් වෙන්නේ නිකන්. එහෙම එක්ස්පීරියන්ස් එක කළා එහෙම වෙලා බලන්නකො පොඩ්ඩක්. If you experience something like that, you feel like you're blank. You're blank. You don't get anything. මට එකම පාරක් එහෙම වෙලා තියෙන එක්සෑම් එක නෙමෙයි ටූර්නමන්ට් එක. එකම පාර. බ්‍රිජ් ටූර්නමන්ට් එක. එයා මේ තමයි ඇත්තම බ්‍රිජ් ටීම් එකේ කැප්ටන්. එයාට පාර්ට්නර් කෙනෙක් නැතුව මට එන්න කියලා කිව්වා. ඊට පස්සේ මට දුන්න එයාගේ බිඩින් සිස්ටම් එක. ඒකේ තියෙනවා කොළ 4ක් චූටියට ලියලා පොඩි පොඩි ඩීටේල්ස් ගොඩක්. He could have given me earlier, but he gave me just before night before the tournament. Like say 8 o'clock වගේ දුන්නා. ඒක පුළුවන් මෙමොරයිස් කරන්න. I memorized everything. ඒ පාන්දර දෙක වෙනම මෙවර ඒක බලලා මෙමොරයිස් කරත් they were like nearly 5,000 details. ඒක patterns. ඊට පස්සේ ඒක කාඩ් ගේම් එකක්. ඒකට ඉන්ටර්නැෂනල් ගේම් එකක්. හරි. ඊට පස්සේ මම ගියා දැන්. කායක ඇවිල්ලා පොලිස් ග්‍රවුන්ඩ්ස් වල තිබුණේ පොලිසිය පහු කරනකම් ඔක්කොම මතකයි. පොලිසිය පහු කරලා ගියා කොහොමද පොලිස් ග්‍රවුන්ඩ් එකට ගිහලා අර ඉස්සර වඩන පස්සේ ඔක්කොම බ්ලැන්ක්. මොකුත් මතක නැහැ. So I respond to එකන පොඩි මේ conversation එකක් කියන්නේ. දැන් මම බිට් කිරීමෙන් මම පොඩි message එකක් යට දෙන්නේ. All my messages were wrong. ඒ මොකුත් මතක නැහැ. ඊට පස්සේ අපි we became the table bottom like අපි තමයි කියන්නේ last team එක උනේ. එහෙම වෙලා නැහැ කවදාවත්. එදා last team එක. කට්ටියව මේ යා හොඳ ප්ලේ කෙනෙක්. එයාව බොටම් එකට ගත්ත එක ලොකු දෙයක් කියනවා. එයා හැමදාම උඩ ඉන්න මාත් උඩ ඉන්නවා. අපිට අපි දෙන්නගේ මිස්කමියුනිකේෂන් එකකින්ද අන්තිමේද අපි. එහෙම වෙනවා. එතන මේ බ්ලැන්ක් යනවා එහෙම මොනවද? මොකද අපි බ්ලඩ් සර්කියුලේෂන් ගන්නේ මසල්ස් වලට විතරයි. එහෙනම් කවදාවත් පැනික් වෙන්න එපා එක්සෑම් එකේදී. right. නැත්නම් මෙහෙම ගියොත් දැන් අපි මෙතන you say you do 1.5 and 3 problems that takes you 8 to 85. 85 කියන්නේ හොඳ result එකක්. Like with 85 marks for math or one subject, you might end up with in top 40. For sure, it's a merit. Probably top 30. 30 again. Top 30 rank ඇතුළේ ඉන්නවා මේ ගන්නට කරන්න. පැනික් වුණා නම් ඉතුරු මොකද ඔක්කොම බ්ලැන්ක් ගිහිල්ලා එකක්වත් ස්කෝර් කරන්නේ නැහැ මෙතන. So you might end up with like 60 a C. C එකක් වෙන්න පුළුවන් මෙතනින් හැර පැනික් වුණා. ඉතින් එහෙම වෙන්න එපා. වෙලාවකට බුද්ධි දන්න එපා. Simply ඒ යන ස්පීඩ් එක කරන්න. හරි. Okay. So I'll see you next week. But next week බලන්න ඕනේ දැන්. If I give you the paper on Wednesday, you don't have enough time to do it. Right, because we have some other classes and other engagements. So therefore, probably we can delay the discussion by 1 week. Then it will be more effective. Right. Okay.